So the whole reason we use significant figures in our calculations in order to communicate error is because we also want to get an idea of how good our data is. How reliable is it? Are we just taking measurements and they don't really mean anything? Or do those measurements have, a true description of what it is we're trying to measure? So we know that the more significant figures we write down, the more digits, the more certain we are about our measurement because we're writing more numbers down. And we can use this to look at how precise our measurement and how accurate our measurement is. So when we're talking about accuracy, we're talking about how close to the real value is our data. So how close to the real value is our data? The closer it is, the more accurate. Now it's true, we don't always know what the real value is. I mean, that's the whole point of measuring it. But there are ways that we can ensure that we're getting more and more accurate results, that the numbers we're getting really are representative of the actual value. A precise measurement, on the other hand, is how do we get, or how often can we get the same result for each measurement? So each measurement is the same each time. Uh-oh, my screen's too little. Same measurement each time. So I think the best way to represent this pictorially is with darts. So when I'm playing darts, of course I'm being really accurate if I throw a dart and I hit that bullseye. That's a pretty accurate measurement there, my little yellow dot, right? And I know it's accurate because I know the real win here is hitting that bullseye. I know what the correct answer is in this case. It's hitting the bullseye. So that's an accurate measurement, my little yellow dot. So a precise measurement, on the other hand, let's change colors here to blue, might be if every time I throw a dart, I get it in the nearby, right? So in the blue cases, I'm precise in that every time I threw that little blue dart, I got it in the same region, but it's not very accurate because I'm not getting it close to the bullseye. So in our kitchen labs, one of the ways that we're going to ensure accuracy is we're going to take lots of measurements, because chances are the more measurements you take, once you take an average of those measurements, the more representative they are of what that true value is. In order to be precise, you're going to have to make some judgment calls. So every time you take a measurement, you'll have to evaluate how close is it to your other measurements. But that's the difference between accuracy, in this case, and precision, in this case. So you could see, you could have precise measurements that are in fact not accurate.